Welcome everyone to This Is My Offer. I am Antony Prasad, Thevaraj, Senior Partner Solutions Architect here at AWS. And today we're joined with our esteemed speaker, Jesus Barrasa, Neo4j's field CTO, and he's going to talk to us about their groundbreaking work in graph databases and generative AI on AWS. Welcome, Jesus, to our show. And do you want to do a quick intro and then we can get started?
Sure. Well, thanks. First of all, thanks for having me, Antony. It's a pleasure to be here. We've been a long time partners, and yes, I'm like you said, I'm the field CTO with Neo4j, and I'm really excited to talk about our partnership and about graph databases and share a lot of the great things that we're doing.
Absolutely. Thank you. It's a pleasure to have you here, Zeus. Um, let's just start from the beginning, from the history. Neo4j has been an AWS partner network since 2013, and with over 40% of the customers running on AWS. Could you tell us a little bit about, how this journey has evolved over time and how the partnership has evolved, in our Better Together story here?
Absolutely. Yeah, you're totally right. So we have a long and deep cooperation and relationship that does not only involve our go-to-market, but we also work closely on things like engineering and joint product development. So there's things, competencies such as GenAI, which is particularly close to my heart, of course, but also industry-specific competencies like, FS, financial services, and government. And we also work together in things like the service ready program and in areas around SageMaker and Private Link. And I wanted to mention also, last but not least, is we do loads of enablement activities together, globally. And a great example of that is the AWS and Neo4j Gen AI workshops and labs that we do. And I think we're going to talk more about them later, but we put them out there in GitHub, and it's a really great resource.
Absolutely. I think giving that hands-on experience to our customers really helps them understand, how to get started. So thank you, Aziz, for giving us an intro on that. But let's take a step back, Aziz, and help us understand what is Neo4j's graph database solution all about, right? I think that's something that users really need to understand. And how is it helping our joint customers?
Absolutely. Yeah. Well, I guess the key difference, what's special about us, is that we're a data platform. We store data and represent data, but we do it natively, not only capturing data points, but also the relationships between data points. At Neo4j, we believe that these relationships, they're as important as the data points themselves, because when we analyze them at scale, they reveal patterns that are extremely important for our customers' business. And these relationships are nothing but the references between the records in your data warehouse, or the references between the documents in your document database. But you have to look at them as first-class citizens, because, like I was saying, when you look at these relationships, suddenly you can leverage the structural features in your data, and you can not only query your data, but you can look for patterns, look for shapes, look for data in context. And that's extremely important when you want to get all the value in your data. And it's particularly interesting these days, because we've added to this kind of graph representation of data the support for vectors. The advantage of having a very rich collection of retrieval strategies for your data. And by retrieval, of course, I refer to how agents, I'm going to talk about that in a moment, how AI-backed applications, LLM-backed applications get access to your enterprise data. And being able to get data in context, get data with its semantics, is really important. So that's what we do. So we're the pioneers in that space. We kind of create, in a way, that type of data manipulation, data storage. And Neo4j is the platform that specializes and that's built from the ground up to work natively with data as connected nodes and relationships, we call them. The mathematical term would have been vertices and edges, but that's kind of more user-friendly, I would say. And yeah, so we are a horizontal sort of platform. So we create a generic data management graph-based data management platform, but we use in a huge number of verticals and use cases that we'll talk about in a moment, I'm sure. But that's basically what Neo4j is and what's special about us. I hope that kind of gives a sort of an overview of that.
Absolutely. Thank you. So I think one thing that comes to mind as well is, as a recovering data engineer, I think some of the things that you just talked about, the nodes and relationships, writing those in SQL queries would take like thousands of lines of code. But I think using ciphertext, it's like maybe we can simplify that to 1 or 2 lines of code, which is also, I think, something that has really changed the game for our use cases as well. So thank you.
Absolutely. Yeah.
Yeah,
Yeah, totally. And Cypher, for those of you who are not familiar with it, is the pattern-based query language that we invented, and that now it's been kind of standardized under the name of GQL. But yeah, that's you're totally right. I mean, we've thought of data in terms of tables for too long, and when it's more about kind of finding patterns, understanding the context, you have to start doing joins. And yes, we've all been through the pain of the join bomb situation where you know sometimes doing a join is not a problem, but when you do a deep analysis and this join becomes 10 or 20, you see performance degrade, you see thousands of lines of code, hard maintenance, and that's exactly the problem that we address with our graph approach.
absolutely. Thank you. Let's dive into the GenAI architecture. Could you walk us through as is how Neo4j integrates with Amazon Bedrock and Amazon SageMaker to create knowledge graphs, just to educate our users?
Absolutely. So Neo4j is we hold the data, and it's great that we have these reference architecture on the screen for all of you. So we are the center because we hold the data stored and represented as a graph, like we said. But you have to bring data into that database, and that's where AWS plays a key role, because you want to bring into the graph data from all sorts of sources, right? It's going to be some structured data, some semi-structured data, some completely unstructured data, and you're going to build your pipelines to create a rich knowledge graph that will be stored in Neo4j, and then that's the, let's say, the knowledge graph creation part. But then there's the consumer sort of side, right, where applications will go and read from the graph. I was mentioning before in AI applications. You would use retrieval for that. I'm sure we've all heard over the last couple of years many times the RAG approach. We like to call it graph RAG, when the retrieval, the grounding partner is a graph database like Neo4j. So the LLMs are gonna get access to your data in the form of a graph, and that's what you see on the right-hand side of the application. And on both sides, we see the LLMs being involved, particularly important when you're building the graph for things like entity extraction, entity resolution, and the combination of Neo4j builds a really powerful sort of architecture that, like the one you see on the screen. So that's actually one of the ones that we use in our workshops and our labs.
Absolutely. And thank you for clarifying. Like, this seems like a more horizontal, repeatable pattern where customers can use it for their own use cases. But speaking of use cases, Jesus, what are some of the top use cases that you're noticing your customers on the field using Neo4j
Sure.
graph databases for?
Yeah. So there's dozens of them. I'll just I could spend an hour talking, but let me talk about 2 or 3 of the most popular ones. So in the financial services space, I mean, there's a lot of solutions being built around things like fraud detection or anti-money laundering. And again, the idea here is to detect unusual patterns in your data. And when we talk about patterns to me, that's shapes in your data, and shapes is exactly the kind of thing that you need to use relationships to identify them. Let me give you an example, right? So think of in retail banking a sequence of consecutive money transfers between accounts that form a ring, right? A ring is this shape that's formed when money is moved from account to account to account, and it terminates at the same originating one. That's potentially a case of money laundering scheme. So, like you were saying before, I could take my data from a relational database, do a lot of work in memory and try to identify this, or I can run a very simple cipher pattern looking for exactly that particular shape, and that would surface all these kind of cases that would really simplify and make way more efficient this idea of fraud detection. So that's one case. I mean, finding all sorts of unusual patterns in your data in the case of the financial services sector, that would be around fraud detection and anti-money laundering. Another area where we do a lot of work is in supply chain intelligence, right? For example, we use Neo4j to map and analyze all the dependencies across suppliers, shipments, parts, risk. And again, you want to identify shapes. So think of a single point of failure, a point where your supply chain gets strangled because all the shipments go through a particular point. Remember what, a couple of years, 3 years ago, what happened in the Suez Canal? I mean, that's of course kind of an obvious one because it's a geographical bottleneck. But you want to identify these kind of elements in your supply chain to anticipate and mitigate the risk that they introduce. So supply chain is another big area for us as well. We're going to talk later more about in the life sciences and pharma space. We see a lot of use of graphs in scientific discovery, in trials, in patient journey. Again, think of all the steps in the journey of the treatment of a patient as a graph, and you want to find patterns. You want to understand next steps, what happened in the history. So these are just three of some of the common use cases that we see. But like I say, the list is endless, and you can I invite you to go to our website to find more and even see customers doing it.
Absolutely. This is, I think, one thing I've noticed in common in all your use cases that you talked about. It's data that is very interrelated, and you're looking to study patterns. I think Neo4j makes it really easy for our customers to actually pick up those anomalies and predict, the actions based on the data itself. So I think that's really
Absolutely.
fascinating. Thank you. Is there a specific customer that you want to double down on, or even a vertical to showcase where Neo4j's graph technology combined with the AWS GenAI services solved a really complex business problem?
Yeah. I mean, I can think of the most recent one. We've been working together with a big bank here in the UK, and we actually co-presented at the Gartner Data and Analytics back in May. And they've taken a very interesting approach to, like many other companies, they have all sorts of data in the data lakes and the data warehouses, and sometimes it's really hard to find the information that you're looking for, and even harder to try and find and answer questions around lineage, ownership, accountability in that data. So what they've done is they've built a graph representation of the dependencies between. It's kind of a semantic layer on top of their data, and now they can. And that map to the underlying sources makes it possible for them to understand where data comes from, where's data consumed, which are the dashboards that are going to be affected by these pipeline that failed overnight. And they've taken even further, and they use Bedrock to provide a conversational interface to that. So you don't have to be a technical person to write a complex query or even go to a dashboard anymore. You can ask a question, or you can get a summarized text representation of what's going on, or how to interact with your data. I think that's particularly interesting. If you want to know more, you can go to our website, and there's a more detailed case study of the work that we've done together. But it's a fantastic story of success of combining Neo4j and AWS services.
Absolutely. I'm sure the audience will be keen to look into those artifacts. And the other one is your architecture, as was just talked about, some use cases like clinical decision support systems and enterprise knowledge search. How are customers implementing these solutions in the field?
Yeah. Well, you mentioned that in pharma, in life sciences, data is highly connected. So you're right. I mean, but the thing is, these connections are latent there. So someone has to go and find them and connect the dots. So the first step is, okay, let's take all these sources, let's build the data ingestion pipelines, and we saw the architecture in the diagram a minute ago. So you can use AWS services to parse the sources, to do entity extraction when needed out of the unstructured data, or even with the structure also do the more traditional ETL. But you build the graph. That's the first step. You duplicate, you connect, you integrate. I mean, that's some of the more sort of traditional data engineering parts. So they will bring the data into the graph, and once you're in the graph, you start detecting the patterns like we were saying, but that gets enriched with a collection of algorithms that come with Neo4j. So there's the whole, we can very concisely and in a very expressive way, we can literally draw shapes with code and identify them, but we can also use algorithms. And that takes us one step further, because we can find, we were talking before about bottlenecks in your supply chain. So there's algorithms like around centrality. We've all heard about PageRank, about eigenvector centrality. Between the centrality, there's a bunch of those that are capable of analyze your data in the graph and reveal which are the important nodes or which are the more influential nodes, and that will have different meanings depending on what your business is or what your use case is. But this is a whole collection of additional capabilities. I mentioned centrality, but there's also community detection, how things relate to each other through connections in the graph, community detection, path computation, how do things relate to other things, what's the shortest path, what's the longest path, what's the diameter of a cluster in the graph. All these that might sound complex, and that would be complex if you have to go write all the code in Python by loading the data yourself, become just a function call because we offer this collection of algorithms with the Neo4j platform. So these are critical elements in this kind of clinical type of use cases as well. So I would say that these are and then once you've identified these key bits of information and these key insights, what we're seeing these days is that there's an additional sort of surface to interact with the graph. The graphs are very visual, and Neo4j offers the Bloom platform to be able to visually explore and navigate the data. You can write queries if you're technical, but now I was saying there's this new amazing surface, which is English language, well, English, French, or whatever your preferred language is. We can talk to our data, and that's where Bedrock also is playing a very important role, because it simplifies the construction of conversational interfaces or natural language interfaces that will make your data even more accessible and democratize it, as we like to say these days, even more. So I think these are key elements of these type of solutions.
Absolutely. I think I like your phrase, talking to data. And I think that's what customers are looking to do, right? Talk to the data and derive useful narratives out of the convoluted data itself. So appreciate those insights, Jesus. Looking ahead, let's talk about what's next on the horizon for Neo4j and AWS in the Gen AI space that customers can be really excited about.
Yeah, that's a great question. I mean, I like to think of these as, I mean, even in terms of use cases, I have the impression that we're only scratching the surface. Things are only starting. And what we're seeing is a lot of our customers, and I'm sure that's a shared opinion, they're starting with the simple problems. It's like, let's introduce efficiencies here. Something that used to take a whole week of analysis. We'll talk about some fraud investigations, or even research problems. I mean, we can now deploy an agent that will do that in a fraction of the time. So we will simplify some of the, well, not simplify, but become more efficient. And that's great. That's amazing value already. But I think what we're going to see in the coming months is way more transformative use cases. And this is hard to even describe, because it will be a combination of a much better understanding of the capabilities in this new generative AI technology, in combination with a good understanding of our customers' business. But I think that's going to get even more exciting. So I think this sort of transition into more transformational use cases is something that we're going to see. But then coming to Neo4j, yes, there's a lot of interesting things coming up. So we're investing heavily, and we want to add over the next few months a good amount of additional capabilities, things around support for unstructured data. I mean, we talk about the process of dealing with unstructured data involves, chunking data sources, even doing entity extraction to build a rich representation in the graph. We want to really simplify that, and we're adding additional support for these. We're adding additional interfaces to create agents on top of the graph. So that's another thing coming up. And very interestingly, I've talked about the algorithms, the whole analytics capabilities in Neo4j. We're now, and this is not a future, this is a real thing that's existing now, is you can use these analytics capabilities in a sort of serverless fashion. So you don't need to move the data into the graph. You can leverage the data from external sources, and you run your analytics in memory, and then maybe persist it to a graph, or maybe put them down your existing pipeline. So all these are very interesting and exciting features that we're going to see coming up in the next few months. So watch this space, because interesting things are coming.
No, absolutely. I think there's a lot of things that you touched upon, Jesus, that are really exciting for our customers. Really looking forward to innovating with you guys and how we can take the positioning of graph to the next level. And then I think you've shared a lot of useful insights, Jesus. But then for an organization just starting out, right, starting their Gen AI journey, what's the best way to get started with Neo4j on AWS?
Yeah, very good points, and I love this kind of call to action at the end. So I would recommend three main sources. I mean, for to get the fundamentals, we have a great collection of self-paced courses in what we call the Graph Academy. So we're going to share the link with you, but that's continuously updated by our teams, and we'll give you the foundation on graphs plus LLMs. Then the next step would be to combine it with for example, Amazon Bedrock, and for that, there's nothing better than the labs, the materials that we use in the labs that we run together, and these we make them public in GitHub, and you can just get them and run them, and that's also going to be accessible to you. And then if you want to take it to the next level, and you are at a position where you think you have a project that could benefit from a larger deployment, then there are very, very generous incentives from AWS in terms of giving access to the different platforms, a number of credits to use in the context of evaluations. So it's very well defined, but that's yet another avenue that can be the next step, assuming the first two had been successful. So again, we'll provide details on this incentive program in the link below. And I would say that these are probably the three steps to success with graphs, AWS, and GenAI.
Absolutely. No, I really appreciate those insights, Jesus, and I'm sure the users will be keen on getting their hands on, with the hands-on workshop that you talked about. Thank you. I really appreciate all the insights, Jesus, and really talking to us about Neo4j solution on AWS. As an advanced tier partner, and a very strategic partner of ours, you guys have been investing with us for a long time, and we hope that you continue to invest with us and drive those innovative solutions to our customers. I think we want to continue building on this momentum, and we can achieve greater success together. As always, the better together story with our ISVs in the space. For our viewers, I really appreciate everyone's time and your presence and attention to detail. For more details, I would urge you to check out the links that Jesus just talked about. And to get started, the best place is to get started with Neo4j on AWS Marketplace. Thank you so much, Jesus.
Thank you very much for having me. It's been a pleasure.